about updating the thermal guidelines. We're going to have new ones come out. This is one of the books. I don't know whether you can see this. So this is the first book that we published in 2004. And we updated it in 2008, and then the new one will come out probably
Sometime in winter.
sometime in winter, okay. I looked at him because he's kind of controlling this, okay? So it will have the new environmental guidelines in it on temperature and humidity, and again, those are going to be important to look at. So we'll look at the interface, I'll say, between the IT equipment and the facilities, okay? What does the IT equipment require, and what does the facilities have to do to meet those requirements? We'll talk about the thermal report, the ASHRAE thermal report, number 3 on this list. And Don talked about the last one there. Typical refresh rate for IT equipment could be as little as 3 years. And again, the facilities are designed for maybe 20 and 25 years. Here's some terms, let's see. PUE, really important metric. It's sort of become a de facto standard, I'll say a starting point for benchmarking your data center. For benchmarking your data center or for looking at your new design. So Don gave you a couple numbers. He talked about the internet data centers, 1.1, 1.2. For the enterprise data centers, I'll say what the vice president of the bank talked about this morning, where he had a lot of redundancy and could not have a data center fail. He had to have disaster recovery and a lot of redundancy. That data center may be designed, I'll say, somewhere between 1.4 and 1.6. So it has more redundancy, more equipment. You can't probably have the lowest PUE in that sort of data center. So internet data centers may be a very low number, like Don talked about, 1.1, 1.2. Enterprise data centers are going to have a higher number. But again, it's sort of a range you can judge your data center designs against, and you can kind of see where you have to improve on your efficiency. If you have data centers that have a PUE of 2.5, you're probably wasting a lot of energy. You're probably wasting a lot of energy. So it's really start to look at where those inefficiencies are in that data center. And we'll talk about those more as we go through these slides.
Roger, maybe we should say the enterprise data center will be the financial services.
Financial services for the enterprise type data center. But it's not only financial services. It could be the airlines that run the airports, that control the airlines in the sky. You don't want those data centers to fail while you're up there, ever. Or hospitals that are critical for keeping people alive in hospitals. You can't have them fail. Mission critical facilities. So those sort of facilities have a different requirement as far as maintaining uptime throughout the year versus what an internet data center is. I think we're okay there. So Don talked about this, but let me just say one other word about this and just to talk about it in a little different terms. So surveys have been done, I think Don talked about it, several surveys around the world on PUE, what the average is. And there's surveys out there, 2.3, 2.4, 2.5. So I'm going to restate it differently. PUE of 2.5, what that means is 2.5 watts goes into the data center. Only 1 watt gets to the IT equipment. Let me restate that. 2.5 watts goes to the data center. Only 1 watt goes to the IT equipment. That's not good, right? The whole reason for a data center is the IT equipment. The whole reason. The infrastructure, yeah, we have to use that to support the IT equipment. But really what a data center value is really the bits and bytes, what come out of the IT equipment. So you want the piece of the pie shown in this chart, you want the piece of the pie for IT equipment being more like this, if you can get there. So that'd be the challenge, right? That'd be the challenge. How do we really improve the efficiency of that piece of the pie when you're operating data centers and when you're building new data centers? How do you do that? That's the main focus of this meeting here today, and I don't want to discount the work that the IT manufacturers are doing here. The industry is doing a tremendous lot of work on improving performance of the IT equipment. So if you look at performance of IT equipment over years, no other industry can match the performance of IT equipment. No other industry. It's probably a factor of 1,000,000 times improvement in energy per transistor over the last 4 decades. Let me restate that. 1,000,000 times improvement in energy per transistor over 4 decades. So there has been enormous improvements in the IT equipment, but we still have more room to improve. Okay, we talked about these books, and they're all in this format. So you can download these off the website, off the ASHRAE website. They're all in this sort of standard format.
Sorry, if you pay.
If you say, yeah, it's not that expensive. So this is another one. This is actually this one right here. Another one. Okay, so you can see, they're nice formats for your library, if you will. And we're in the process of actually writing 3 more books. So 3 more books will probably be out
Winter.
winter. Okay, so let's get into the topic to kind of answer, what are the requirements for IT equipment? And this is really important for, again, operating the data center and designing the data center for IT equipment. Key is what the specs are, what the classes are, ASHRAE classes. Contamination is a new one. And I say it's a new one because gaseous contamination is kind of a new thing that's, I'll say, shared an ugly head in the last, I'll say, 3 or 4 years. And I'll talk to you why that has occurred. Thermal reporting, how does the IT equipment manufacturers report their, I'll say, environmentals? I'll talk about that. Power usage and trends, I'll talk about that because we are in the process of updating one of our books on power trends, and we're going to update it to 2020. So it's important when you design your new data center for 20 years to know what our power trends are out in time, so you can get a feel on what you should plan for on that data center as far as power density. Okay. Airflow through IT equipment and some IT basics, so let's get into it. So we started the group, the technical group, Don and I, in 2002. And the first book that came out, as Don mentioned, was this one. And so why is this important? It's a thin book. See, there's how many pages in it? It's only 50 pages or so. Before that, none of the IT had I'll say, a common temperature and humidity guideline. We did not have a common temperature and humidity, so we all had our own temperature and humidity for our own products. So for data centers, one IT manufacturer goes up to 30C, another one 27C, another one 32C. How do you operate your data center? It was a mess. It was not good. So the IT manufacturers, this first book was, I'll say, coordinated amongst 15 major manufacturers, IT manufacturers around the world. And we all agreed to these guidelines. And again, the first one was published in 2004, and we're just about ready to update it with our 2011 version, which I'm going to talk to here. So prior to that, all the books came out. Most of us around the world, thought about controlling our data centers to 20C, 20C, or 18C, or something like that. How many of you had knowledge of controls of data center to something like 18 to 20C? Does anybody know those? Hold your hand up if you've heard about 18 or 20C, 5, 10 years ago. Any of you? None of you? Okay. So again, I'll say back in the 90s, even the 80s, early 2000s, this was the number. So the number was out there, but where do you measure that temperature? And this is another unknown, right? I saw in some cases people would have temperature probes or temperature thermometers on the wall. Or they might have it at the inlet of an air conditioning unit, which, you kind of think, well, what does that mean? Again, what we're trying to look at is the interface to the IT equipment. The interface to the IT equipment is the inlet air conditioning, the inlet air to the IT equipment. So we'll talk to that. We'll talk about recommended temperatures. Again, where are the recommended temperatures located? And I'll talk to where that measurement is, and that 27 you talked about, and I'll talk about that. So 2004 the first time, 2008, the new one will be 2008. So here's the new one. I'll just start. Recommended is 18 to 27. Again, all the IT manufacturers agreed to this. Legacy equipment or new equipment. Legacy or new. 18 to 27. So how many know what when I say something cold aisle, hot aisle? Cold aisle, hot aisle. How many know that terminology? Okay, not very many. I'll talk to that. Important best practice is how you arrange data centers for IT equipment. How do you arrange data centers? So we would say the cold aisle, where the cool air comes from the raised floor or from overhead into that area where it gets ingested into the IT equipment, that air should be recommended between 18 and 27 C. Now I know I looked up the Moscow annual temperature. I looked that up last night. Actually, it's a good climate. It's a very good climate. Let me just say the temperatures, and you see if you agree with these. I thought it was a little warm. In the summer, in July, the max temperature I saw on the chart I saw was 24 C. 24 C? Would you agree with that or not? Higher? Yeah. Higher? A lot higher? 30? 30? 30? Okay. I must have looked at the wrong chart. So still 30 degrees C. Go ahead.
Last summer was very high temperature to 37.
Ooh, that's hot. Wow. That's hot.
Yeah, really.
That's hot.
Really.
Yeah. I'm glad you said that.
It was record.
So 37, yeah, is high. So try to relate, let's say 37 now in the summertime to this 18 to 27. Okay? And again, the idea is how do we now, let's say this is a data center and each chair is a rack and the outside is 37, how do I make sure the temperature that I cool to from the outside of 37 down to 27 at each of these racks? That's how do I do that? Most cost effectively and most energy efficient way. That's what we want to do.
За счет увлажнения.
What's that?
Humidation.
Yeah, right.
Adiabatic.
But let me just, so in the summer, in July, it was 37, okay, this last summer. But in your winter, it's cold, right? Minus, I don't know, you tell me, -5, -10?
-20.
-20, okay. Okay, very cold. So think about this, when it's cold outside, and I'll say several months, I'll just say 6 months, you're below 10 C. I don't know, is that right? 6 months, below 10 C on average? 10 C, if you're below 10 C, 6 months, what would that tell you related to 27? I don't need chilling, right? I don't need air conditioning. I ought to be able to do something in my mechanical design to tie into the outside cold weather at Moscow to cool that IT equipment. Should be very energy efficient, right? So we'll talk about that. Okay, best practice. So I told you cold aisle, hot aisle, right? A best practice is to arrange the IT equipment in what we call cold aisle, hot aisle. Okay. That means you face the IT equipment in one direction. So if the cold air is coming up from the raised floor, let's say this is a raised floor, everybody know what, raise your hands if you know what a raised floor is. Okay, not everybody. So, if this was a raised floor, this table, and this table was spread across the whole room, and I could walk on this, I would call that a raised floor. And the racks would be placed on top of the raised floor, okay? And I would blow chilled air underneath the floor. Blow chilled air underneath the floor with air conditioning. And then the chilled air would come up through perforated tiles in the raised floor. Okay? Those perforated tiles would exhaust the chilled air into the cold aisle, and then that chilled air would be sucked into the servers. And the servers would face the cold aisle. And then the hot aisle, okay, the hot aisle, well, the air exhausts out the racks, out the server racks, back here. Then this goes back somehow to the air conditioning units. Okay? So you get the setup, cold aisle, hot aisle, best practice, and then cold air could be distributed from overhead. You could have, rather than a raised floor, you could have just this floor, and these chairs or the racks, and the air would come from the ceiling, from ducts from the ceiling. Okay? Still cold aisle, hot aisle. So what are the requirements again? The requirements are recommended 18 to 27. Okay, 27 max. And I'll talk more. So the only thing that IT manufacturers are concerned about, the only thing, is the air inlet. We do not care about what comes out the back of a rack. We do not care about that. Other people in the data center may care about it. Other people, but the IT manufacturers, the only 4 things we're concerned about: temperature, humidity, particulate, gaseous contamination. 4 things. Okay, important definitions. And now I'll show you the chart of them. Important definitions. Recommended, that's what I just talked to you. Recommended, we define the IT manufacturers what a recommended envelope is: temperature and humidity. And the reason we define that is for high reliability of our IT equipment and the most energy efficient. 2 things: reliability and energy efficient. Okay, that's a smaller envelope. And I'll use the temperature, dry bulb, 18 to 27. However, the IT manufacturers test their equipment to a much bigger envelope, much bigger. And we usually put them in what we call elevation chambers. So they're chambers which we can take the equipment up to like 3,000 meters in altitude. And we can change the temperature over many extremes. And we can change the relative humidity over many extremes. So it's a much bigger envelope. And we say that envelope is where our equipment operates. It will perform there. It just may not perform reliably for long periods of time if you stay in that larger envelope. So I'll talk to that on the next chart, or next couple charts. So again, in 2011, we're coming out, we just got the white paper. The white paper is on our website, the ASHRAE website, which I think is later, it's detailed later in this presentation. You can pull down free of charge this ASHRAE white paper. It's free of charge. And the reason was, why did we do these new guidelines? And it was really the customer base for IT equipment wanted higher temperatures so they could use their outside climate more to their advantage. So when you were 37 here last summer in Moscow, if you had equipment, let's say, that ran to 40 or 45 C, then you could use the outside climate more to your advantage. So it was to reduce the number of chiller hours. That's one reason, and enable greater use of economizers. And we'll talk about economizers, both Don and I, in our presentation. So we developed, ASHRAE TC9 developed 2 new classes with wider envelopes. And let me show them on the next chart, next couple charts. So here's 2008. The 2008 version of this, which is my book right here, this is what we had. We had 4 classes. We had 2 data center classes, 1 and 2, and we had classes for office and point of sale. So we're really talking up here. And these were kind of divided up into 2 categories, enterprise storage and then volume type servers. But these kind of been coming together, I'll say, over time. So in 2011 here, we defined 2 new classes. And we called these, now we're renaming this to A1, A2, A3, and A4. And the 2 new classes are A3 and A4. I think we've talked about mission critical facilities. And again, mission critical is so it never fails, right? 365 days out of the year. Hopefully it never comes down. The airlines, the financial areas, hospitals, things like that. Listed down here. Emergency dispatch, hospitals, military installations, government emergency. The data center cannot fail. So how many know psychometric charts? 1?
No.
2? 3?
A lot of
At least
people.
1. Okay. Maybe 10. Maybe 10 of you. Or a dozen. You don't have to know this, but I'll just generally say some of these points on here. And I think you'll get the idea from basically temperature and relative humidity. We'll talk in those sort of terms. But again, back, I'll say in the 1980s and 1990s and early 2000s, most data centers thought of this sort of point as the temperature, the kind of temperature and humidity in median data centers, 22C and 45% RH. 22C, and again, where do you measure that? Again, like I said, I found some temperature relative humidity measurements on the wall, which doesn't mean a whole lot. Again, what's required here is the inlet conditions to the IT equipment. That's the important thing. So here's dry bulb temperature, here's what's called dew point, and here's the wet bulb, and here's the relative humidity, okay, 45%. I don't want to make this into psychometric chart. So let me go to this one. I'll come back to that last chart here. So here are the charts. This is the important chart. And again, you don't have to know psychometric charts. So let me point out the key points on this. Let's start with recommended, okay? From a temperature standpoint, the recommended, again, all IT manufacturers agree to these points. And this is for legacy or new equipment, new IT equipment, legacy or new. So 18 to 27 is there. So we're saying we would like to operate the cold aisle, 18 to 27 C. And then we have humidity requirements. We have it basically at a dew point here, a dew point here, and this is an RH of 60%. We tried to make it, I'll say, a rectangle, but we weren't able to on 60%, because what happens, printed circuit cards, if you go above 60% for long periods of time, they will have some filament growth in, which will cause them to short out. So it doesn't mean you can't run above 60% for maybe short periods of time, but you don't want to run 80% for weeks and weeks on end. So again, you want to try to stay within that box, 18 to 27, most of the year, and then the moisture boundaries also. So let me continue on. I'm going to come back and talk. So the allowable is when we test the equipment to the larger envelope. And the equipment that the IT manufacturers make today are in these two classes. All of us make equipment in A1 and A2. Okay, and this one right here is 32, and that one's 35. So we all make equipment to 32 and 35. And again, if 37 in the summer, and you have 35-degree equipment in your data center, you can't just blow in outside air into your data center. It's not cool enough. So you got to do some refrigeration or some cooling, right? But in the winter, you ought to be able to use the outside air much to your advantage and turn off air conditioning equipment. Okay, so the push has been from customers around the world to ask the IT manufacturers to make equipment to higher temperatures. Again, if Moscow is 37 in the summer, you would ask maybe why don't the IT manufacturers make equipment to 40 C? If you had that, maybe I wouldn't need air conditioning. So we produced these two new classes, 40 and 45. That's hot. That is real hot. However, we do not make equipment there today. None of us do. So you can't buy equipment in either one of these anywhere now. So we have a mismatch between, I'll say, what the ASHRAE published new guidelines, A3 and A4, and what the IT manufacturers have in their portfolio of products. But I guarantee there's going to be a rush over the next probably year or two to make products in that area, because customers, marketing, sales is saying you want it. So we will probably start to make products out there. So there's going to be a slow movement, probably, moving towards these higher classes for IT equipment. Today, for data centers today, we got to look at those classes right there. So let me talk about a couple things here, and then maybe we take a quick break. It's been about an hour already. Let me just talk a few things, and then we'll come back after the break. So I said recommended is here. So 27 is fairly warm, right? And I say it's the inlet to the servers, the inlet condition. So when I move air through the server, it heats up going through and it comes out very hot at the end, right? Very hot. So the process on this psychrometric chart looks something like this. It's straight across, no moisture, right? You're just sensible heating. So it goes across, and what comes out, if I go in at 25C in the front, I may come out the rear of that server 50, 55C. It's hot. It is hot. So we all designed our equipment to do this. We designed it this way. We designed it again for the inlet conditions. Okay? So what does it mean if your air conditioning unit fails near a bunch of racks? If you had an air conditioning unit here, and these were racks, if this air conditioning unit fails, what's going to happen to that temperature in that area? It's probably going to fall outside this recommended chart, right? It's going to fall outside of this. Let me erase some here. So it may fall out here. That's probably okay for short periods of time. Again, this is a recommended envelope. For most of the year, we'd like to stay in it. But if you fail the air conditioning unit and it gets hot in this area for short periods of time until you fix that air conditioning unit, that's okay, as long as you don't exceed the allowable limits. So if it takes you a week to fix that air conditioning unit, it's fine. Fix the air conditioning unit, put it back in, keep your IT equipment running all the time. Okay? That's okay. Another scenario, you may put in new equipment in this area that raises the power density. So the power density now goes up. The temperature goes up in this area, right? And I haven't fixed the problem right before you got that new equipment. Again, the temperature for short periods of time may go out there. That's okay. Until you buy that new air conditioning unit to bring in to put here to provide more chilled air to that area. That's okay. So hotspots temporarily created by failed conditions or new servers that are storage brought in, as long as you stay within the allowable limit, is acceptable. Okay? But long periods of time, again, you should try to stay in that recommended envelope. So let me stop and just ask if there's any questions. We'll take a break. Any questions before we break? Okay, why don't we take, what should we take? 10 minutes? 15? 5, okay. 5 minutes. 5-minute break.